pay-as-you-go model. So deep on-demand resources with no upfront investment. That is great. That is very, very, very good. So if I want to define what is cloud computing, and please remember this, because this is definitely one of the questions in the assessment for the people who will take the assessment later after this training here. So cloud computing is on-demand delivery. So it's something that is on demand, right? It's not that like what I do with the physical on-premises, which means I already have my infrastructure. No, it's on-demand delivery of IT resources. IT resources like what? IT resources can be for compute, can be for networking, can be for storage, can be for security, right? All of these are IT resources via the internet. So that's something important now. In order for me to access the cloud, I need to have internet reachability, and very, very important, it's a pay-as-you-go model, right? You only pay for what you consume. So Sandy is saying something interesting here. It's OPEX to CAPEX, right? So we're going to see in the on-premises, this is a CAPEX model in payment, and I'm going to explain what do you mean by this into an OPEX model that we have. So in order for us to really explain the difference between the on-premises and the cloud, so maybe your customer is coming to you asking this question. I have an e-commerce website, for example, and I'm not sure whether to have my own physical data center, or I heard about cloud computing and I heard about AWS. What do you think? You are my partner. He will come to you asking you, you are my partner, and you can help me taking this decision. What do you think, right? So let's take both examples here. If I have it on premises and if I have it in the data center, and with this, let me use the whiteboard. So this is the option if I'm going to have it on premises, and this is the option if I'm going to have it on the cloud. So this is an on-premise solution. We're going to dig deeper and understand how can I build it. And this is my AWS cloud. So let's see it step by step. In the on-premises, what do I need to have? First of all, in the on-premise, you need your physical proximity, right? I need this location, this building, where I will put my racks of servers, of networking, of storage, of load balancers, of firewalls, right? So you need the physical proximity, and you need to either buy this physical proximity or I need to rent it, right? So the customer either need to buy the physical proximity or he needs to rent it. And then we come to something very interesting. What about my sizing? Because this is a very big differentiation between the on-premise and between the cloud.
That's how you can do it. Then you start looking for freelancing work from all these other places.
I can do the sizing based on two options. So I can do the sizing based on something called the average workload coming into my website, coming into my infrastructure. But here, there is a problem or there is a challenge. If I did my sizing based on the average, right, what will happen during the peak times? So let me give you this example. If I am doing an e-commerce website, and maybe I have a sale, something like Black Friday or something like a Christmas sale, for example. During this sale, I usually expect double the traffic or triple the traffic. And during this kind of sale, you are expecting lots and lots of extra revenue coming to you, right? So you can definitely not afford to lose this kind of revenue. So you need at the peak times, you need your infrastructure to be working as perfectly as possible. Yeah, and please, if you're not speaking, if you can just mute yourself. Otherwise, if you have a question, because I can hear a bit of a background noise. Okay, thank you. Thanks a lot. So I can do my sizing based on the average, but what will happen during the peak times? Sorry, but I can still hear background noise. Please, if you're not talking, just please mute yourself. All right, thank you. So if I did it based on the average, what will happen during the peak times? My infrastructure is going to be overutilized. Overutilized means when traffic is coming to my infrastructure, this means that my infrastructure will be overutilized, so it will not be performing well, and I might have some application degradation. So imagine if customers are coming to your website on the sale, they need to get lots of stuff, and your application is crashing, for example. They are getting some bugs or some errors. So very easily, they can just go to your competitor, for example, and get something similar. And that's why usually during the peak times, I don't want to afford having any performance degradation. And that's why you will find, and when I was working as a solution architect as well, we always do the sizing based on the peak. So you will tell me, although with the peak, I'm getting extra infrastructure, right, that I'm not going to use all the time. I'm only going to use during the peak times. And the important question, do I have peak times frequently? Not really, right? You might have it maybe once a week. You might have it once or twice a month, for example, whenever you have a sale. So it's not something that is happening quite often, right? But in order for me not to lose any traffic during the peak times, I'm going to size it based on the peak, but I know if I did the sizing based on the peak, my infrastructure is going to be what? Underutilized most of the time. So I know that I'm paying extra because I want to be in the safe side, right? And this is the sizing, and this is one of the major things that we can solve using the cloud. Now, something very interesting is the waiting time. What about the waiting time? From your experience, can you tell me now, I have this customer, we have done the sizing based on the peak. Now, this customer needs to place this order with the infrastructure vendor, right? So he can purchase the equipment on site. What do you think is the waiting time? How long will the customer wait till he has this infrastructure on site? What do you think? From your experience, for 4 to 6 weeks. Definitely, that is something. Is it scalable or is it flexible for scalability? That's what exactly we are discussing here. That's why we're having the two comparison between the on-premise and the cloud or the AWS. So Angelique is saying from 4 to 6 weeks. What else? From 3 to 6 months. Yeah, and there is the administration cost as well. But what is the waiting time? What do you think is the waiting time? If you have worked with an infrastructure vendor before, when I place an order with the vendor, right? How quickly I can get my servers, my storage, my networking, my racks. How long do I need to wait to get my infrastructure on site? Any other guessing? 4 to 6 weeks, 3 to 6 months? Any more guessing from your experiences? All right, so 3 to 6 months. Okay, so let me tell you this. What is the waiting time? This question actually has two answers, right? It's before COVID and after COVID. What do you mean by this and why we have this separation? Because before COVID, The average waiting time was around from 8 to 12 weeks, which was around 3 months. The average waiting time before COVID was around from 8 to 12 weeks, around 3 months, right? But after COVID, something happened, and I'm sure you heard about it in the industry, what we call the semiconductors shortage, right? Semiconductors are crucial components inside every smart device. So everything that you use, like TVs, like screens, like laptops, like washing machines, like refrigerators, like cars as well, right? It has this smart component inside called the semiconductor chipsets, right? And because of the huge rise of demand after COVID, now we have a global shortage in the market about these semiconductors. And that's why right now, the average waiting time is around 6 months. And I can tell you that there are some vendors as well, there are some hardware vendors that their average waiting time can even go up to 9 months or one complete year. Can you imagine? Up to one complete year. So before you place the order, they will tell you, sorry, the order, you can get the lead time of from 9 to 12 months. So Hamza is sharing his experience here. I faced this problem myself as a manufacturer of the IoT device. Lead time is around 8 months. So thank you, Hamza, for sharing your experience on this. So now the waiting time, so I will just say the average waiting time is around 6 months. 6 months means what? Means I have done my sizing, right? I have my on-premise waiting for the equipment to come, but sorry, you will need to wait up to 6 months. But now the question, now I waited 6 months and now I have the equipment on site. So the question, how long do you need to have your infrastructure up and running so you can have this e-commerce website active? What do you think? How long is the time of deployment? I need to get this infrastructure. I need to put the racks, right? And I believe you have all seen physical data centers before. So I have my racks of servers and storage like this. And then you do what we call the racking and stacking. So you have the equipment and you have the team doing the racking and stacking as well. So this means after 6 months of waiting, I still need the team to do the racking and stacking and the cabling and the patching, right? And then they need to install the virtualization software. And then they need to start working and generating these virtual machines. And then you can be up and running, right? So imagine all of this time. So this means that a waiting time of at least from 9 months to 1 year in order for you to have this application up and running, right? And what about the payment model? The payment model here is what we call CapEx, right? So CapEx means it's a bulky investment, right? I pay the amount of money just on one shot, and that's a capex model here. So it's a bulky investment. So let's see the model of the cloud now, and if with the cloud we can really overcome all of the problems that we mentioned here. So with the cloud, let's see the first problem. With the cloud, do I need to buy or do I need to rent any physical proximity? And the answer is no. You're definitely renting this from AWS. So you don't need to worry at all about your physical proximity here. You don't need to buy it. You don't need to rent it from anyone. This is very good. That's number one. So I don't need to even look for these physical proximities. Number two, which is very, very important. What about the sizing? On the cloud, do I do the sizing based on the average or do I do the sizing based on the peak? And the answer is on the cloud, I do the sizing based on the average. So, for example, if I'm building my infrastructure, right? So I will start my sizing, maybe I need at least, just for the example here, 3 servers to serve my clients. But now the question will come, Rafi, what will happen at the time of peaks? And please pay attention here. So what happens here? Using the cloud, and this is one of the big benefits of having the cloud, I can start with just the average of instances that can power my website, that can power my infrastructure. But then, what will happen at the peak? I can leverage the cloud. I can leverage a service on the cloud called ASG, Auto Scaling Groups. What is ASG doing? ASG is a service running in the back end that will monitor my, for example, CPU utilization of these servers. And then you can specify the threshold, for example, of 70%. So this means auto scaling groups is monitoring the CPU utilization of these servers. And if I reached more than 70%, now I will understand, now I'm having extra load coming into my website. These servers are going to be utilized more. And I know, based on my application, that 70% is a lot, and maybe my applications will not be performing well. And that's why what will happen? An automatic scale out. So automatically, ASG, this service is running in the back end, will initiate extra instances on your behalf. All right. So now I can serve more customers, right? Now I have my peak time. So I have lots of other instances that have been generated. And then when my CPU is getting back to less than another threshold, maybe 50%, now I can go and then I can terminate these instances. All of this is completely automatically, and this is what we call scale in. So I can do an automatic scale out, and also I can do an automatically scaling in. And what will happen to these two instances? How do I pay for these instances? I pay just during the time when these instances were up and running. So for example, during the peak was a sale of maybe 2 or 3 days of sale, right? So you are going to pay for these instances only for 2 or 3 days. Did you get this? And this is one of the features that we call elasticity. So elasticity here means I can have more instances automatically, right? Using this scaling out, or the service itself, it's called auto scaling groups. And I'm going to explain auto scaling groups again in future modules. So the sizing, how can I do my sizing? Now you're going to see we have lots of cost saving on the sizing right now, because I don't need to do based on the peak. I don't need to just buy infrastructure and do nothing most of the time with this infrastructure. Let me even tell you something else. What if you want to do some testing? Maybe you want to try something new. If I want to try something new on premise, what do I need to do? You need to get the equipment. You need to buy all the equipment. You can do whatever testing that you want, or lab environment. What if you're done with your testing? You still have the infrastructure, right? But on the cloud, I can power some instances, do whatever testing that I want, maybe for like a couple of days, couple of weeks, or whatever, and then I can completely terminate this environment, right? I don't need to pay for this environment for the future. Can you imagine all of these benefits I'm getting with the cloud? And finally, about the waiting. Do I need to wait for the cloud? No, because simply you have all the services. And if we have time, I'm going to show you an example today of how I can have a web server up and running in just a few minutes. So how long do I wait in order to have my cloud up and running? I just wait few minutes. And this is a real number. Even if I have a very complex design where I have lots of services and components from AWS, do we have a way to automate something like this? Yes, we have a way to automate something like this using something called infrastructure as a code. I'm going also to mention this in the coming lessons. So, is this example clear? Does this example make sense to you? Like, you can put on the chat if you want to say anything regarding your experience about something related to this. But this is an example. If your customer is coming to you and telling you, you know what, I'm not sure, shall I go with on-premises, or I'm hearing now about the cloud and I'm hearing about AWS, what do you think, right? You can simply explain this for him, that he needs a physical location, right? He needs the team to manage this physical location. He will do the sizing based on the peak, and that's why most of the time he will have his equipment underutilized, and then he needs to wait a lot in order to have the infrastructure on site. And now after COVID, even this number is a very aggressive number, 6 months or 9 months. That is a lot for the customer to wait, versus all the benefits that I will have using the cloud. With the on-premise, the payment model is a CapEx model, but with the cloud, the payment model is something called variable expenses. Why it is variable? It is variable because it depends on my usage. So in 1 month, I'm working with the average, so I'm only paying for 3 instances. During the peak, during the sale, I powered on extra 2 instances, so only during this month, I'm going to pay for these extra 2 instances. And that's why it's called variable expenses, because it depends on your usage. So is this example clear with everyone? Any question about this example? Or if you want to add anything from your experience regarding this? Do you agree? Does it make sense to you? Maybe 1 more minute if someone is writing something on the chat. Okay, it makes sense? All right. Very good. So let's see the slide. Yeah, makes sense. A lot of differences. Very good. Exactly. Yes, exactly. 100%. 100%. And right now, Radu, time to market is extremely important. Right now, we're living in a very competitive environment between the companies now. And definitely the company who can be up and running 6 complete months before the other competition. Imagine 6 more months of business, right? Versus the other one is simply waiting for his infrastructure to come. So a big differentiation between the two examples. Very, very good. Any question before we move along? Because this part is a very important explanation on how we can start working with the cloud and how can you propose this to your customers for the cloud. All right, so with AWS, right? AWS, as we explained, AWS will manage and will maintain your infrastructure. You don't need to worry at all about the physical infrastructure that you have. You don't need to secure the infrastructure that you have. You don't need to pay for the electricity. We have this term which we call it keeping the lights turned on, right? Because I need electricity to have this equipment, to power on the equipment. And then this equipment, they dissipate heat, right? So when you are dissipating heat, you need ACs, very powerful ACs. I'm sure most of you went inside data centers, and inside data centers, usually the temperature is extremely low because we cannot afford to have a high temperature inside our data centers. And this means we need very strong ACs. All of this is something that you pay for. I don't need to pay for it when I have the cloud. So from the customer's perspective, all what they need to do is to do what? Is to provision services. And if we have time today, or maybe during the lunch break, I can show you how easy I can just go into my console and provision a web server, for example, that can just be up and running in few minutes. Really, literally in few minutes. So customers, they can leverage all of this from AWS and they can provision these kind of services. So applications definitely are running reliably. And in most of the time, or actually in like 90% of the cases, when customers move into AWS, they report that they have a much better uptime versus when they have the uptime on premises, right? And definitely security, but security is a term that we're going to take it in details. So why customers are moving into the cloud? That is exactly what we explained. So from a cost perspective, I trade the capex, which means that I will pay everything in one shot of a bulky investment versus I am doing variable expenses. I believe now it should be clear. Variable because you only pay for the resources that you use during this month, right? So I pay monthly to AWS. I don't need to pay like multi-million dollars at the beginning. I have seen some huge data centers in the region and they are costing multi-million dollars. Now I can do this multi-million dollars, but I can do it in the span of 5 years. And I can utilize this budget in a much, much better and efficient way. Increase the speed and agility. We explained this in details, that how quickly I can have my application up and running. And something else, agility means I am not bounded to my hardware. What do you mean by this? Let me give you an example. So if you have your infrastructure, all right, and let's say you need to run maybe an HPC application, or actually you need to test an HPC application, high performance computing, that needs maybe GPUs. Not sure if you know the GPUs, which is like a second generation of CPUs, which can do much better. But right now your servers, they don't have GPUs. So again, you need to go through all the sales cycle, or do you just want to maybe try it? So using AWS, you can immediately, in few minutes, power on some EC2 instances or some servers that they have GPU capabilities, and you can test it. Is it worth to have these GPUs? Will it really enhance my application or not really? I don't need it, right? So agility means you are not bounded to your hardware limitation. You can just go and test and try whatever you want on the AWS cloud. Streamline and enhance infrastructure decisions because I can test, for example, and I don't need to do all of this waiting inside AWS. Reduce the expenses for sure, because lots of parameters now, I don't need to pay for it. And that's why definitely one of the main pillars of moving into the cloud is cost reduction. So reduce the expenses. Now this is very nice. Scale globally. What do we mean by scale globally? Scale globally very simply means, imagine the example I mentioned, where I have a customer and this customer is building data center, but imagine if he will build this data center maybe in 3 locations. He wants to serve customers in the US, he wants to serve customers in Europe, he wants to serve customers in Australia. So he will repeat the same steps we mentioned 3 times in 3 different countries, and every country will have its own challenges of importing and exporting and customs and everything like this, right? Now, using AWS, and this is as easy as click of some mouse buttons, right? I can just do some clicks and I can have 3 data centers globally. Because you're going to see when we explain AWS infrastructure, we have this concept called regions and availability zones. I'm going to explain this in details. So customers, with just a click of a mouse, they can leverage the infrastructure that we have across the globe. Increase innovation. Now, what if, for example, your customer heard about something like machine learning, something like AI, something like what Hamza mentioned, IoT, and they want to try it? Imagine if they will do this on site, on premise. They need to build everything from scratch. With AWS, we already have services like this, right? So they can just utilize it, or maybe they can just try it. And by the way, in some cases, when you try it, you get stuff for free for like the first 90 days or the first 1 million requests, something like this. So sometimes even you can try a certain innovation for free, right? And then you can see if this is like increasing your business, then you can even go and purchase it. So increase innovation because we already have these services up and running. And finally, accelerate the time to what? to business value. We try to offload from you, Mr. Customers, lots of tasks that you don't need to do. Why? So you can focus on how can you innovate your business value and make yourself more valuable in the market. Is this slide clear? Please let me know if you have any question, because this is a foundational slide that we have. Why customers are moving into the cloud and AWS. Is this clear with everyone? Any question about this? All right, so I'll assume that this means that there is no questions. So cloud deployment models. Again, that is a question in your assessment for today. What are the options of deployment models? We have what we call private cloud. And private cloud, this is another name for your on-premise. So whenever you hear the word on-premise or private cloud, that is exactly the same, which means I own my physical infrastructure, I own my data center, and I have my infrastructure inside my data center. And then we have what we call public cloud. And public cloud means these kind of customers, they don't have a data center. They completely rely on the cloud. And I can tell you some big names that they have been born on the cloud, and they have been born specifically on AWS, something like Netflix, something like Uber, like Airbnb, all of these big names that you know about, they have been born on the cloud. So means that they are using the public cloud, they don't have any physical data center. And then what we have in the middle is what we call hybrid cloud. And let me tell you, this is the model that we are looking for. Most of the customers that you will meet today, they are here. Most of the customers that you will meet today, they are here, which means they already have an on-premise. And you want to help them either to start by being hybrid, which means moving some of their workloads into the cloud. So when I say hybrid, it means what? It means that this customer has some workloads on the cloud, but also he has some workloads in the on-premises. So this is the cloud, the public cloud, and this is the on-premise. He's using both of them. So we have either the private cloud, which means I'm only relying on my private on-premise, or we have the public cloud, which means I'm relying completely on the cloud, or the hybrid cloud. And that's again a question in your assessment for today. Hybrid cloud means I have some applications that they are in the cloud and some other applications that they are on-premise. So what are the types of workloads that we can have in the cloud? I can tell you almost anything. What kind of workloads can I put in the cloud? I can tell you right now, we have like more than 1 million active customers monthly in AWS. We are running all types of workloads in the cloud. It can be customer-facing web application. It can be some business applications. It can be big data, analytics, HPC. It can be machine learning. It can be IoT, for example. It can be robotics. It can be satellites. We have lots and lots of services that we have in AWS. Some other people, by the way, at the beginning, because they still don't know the cloud, they still don't have the full trust in the cloud, and that's why they start the cloud with what? With DR. They say, you know what? Okay, let's put our DR in the cloud, and maybe we can test it, right? And then later on, when they see over the cloud and all the benefits that you have over the cloud, they can completely migrate, or they can migrate more mission critical applications on the cloud. So what are the AWS advantages, right? First of all, if you ever heard or worked with Amazon, sorry, and AWS, Or by the way, if you will ever do an interview with Amazon and AWS, you need to know something very important called leadership principles. All right? Leadership principles is how we work in Amazon and in AWS. The standards of how we work in Amazon and in AWS. And the most important leadership principle that we have is what we call customer obsession. Customer obsession means we are obsessed about our customers, right? We want our customers to success and to thrive. Why? Because whenever our customers are successful, this means that yourself as an AWS partner will be successful and us as AWS will be successful. So we think about it this way. And the more you deal about AWS, the more you will get the difference that we're not like hardware vendors. We are not just selling something and then we close the opportunity and leave. That's exactly not the case here. With AWS, once we migrate customers to the cloud, this is for us the starting of the journey. It's not the end that this customer moved. No, because once this customer will migrate into the cloud, now he can explore all the services and all the optimization that he will get from moving into the cloud. So whenever you're dealing with customers here, remember that in AWS, we are customer obsessed. We care about the customers, right? We understand or we try to identify what is the customer problem that we can solve with AWS. It's not just, you know what, cloud is the best. Yeah, cloud is the best. Why for this customer? I need to understand exactly his challenge and what kind of service I can offer him in order to overcome his challenge. What makes AWS unique? Let me ask you this question. Do you know when did we start as AWS? In which year? Anyone has this history? Do you know when did we start as AWS? Or do you know how did we start? What was our starting point? Any idea? Can anyone tell me the year we started as AWS, or even maybe some guessing? Two 2007, okay. That's a close guess, by the way. That's a very close guess. 2005, that's another close guess. 2005, okay. So we started in 2006. So you were both very close, exactly, Sandy, in 2006, right? And just a bit of history. How did we start as AWS? We started because this was the IT team managing the Amazon website. And at that time, the Amazon website was becoming like a huge part, increasing a lot. So at that time, we were having this team managing the infrastructure of Amazon.com. And then we found out, we know what? We have some extra infrastructure that we have. Why don't we start renting this infrastructure? So people, instead of relying on their own physical data centers, they can just come and rent this from us. And this is how we started the concept of cloud computing. And this was in 2006, right? So let's see here what makes AWS unique, all of this in the coming slides. First of all, the enterprise leadership. As I mentioned, we started in 2006. So right now we have over 15 years of experience, starting from 2006 till today. And what you see here is the Gartner report. I'm not sure if you are familiar with the Gartner report or not, but the Gartner report is like a group of analysts where they analyzed the market and they started the first Gartner report for the cloud in 2010. And since we started in 2010, I mean the Gartner report, till 2000 or 2021, AWS, if you have ever seen this, has been positioned as the leader in the cloud providers here, right? So check all the last 10 or 11 reports that we have. AWS, as per Gartner, is positioned as the leader in the cloud providers. And then the second one, why AWS? Why AWS? Because lots of services that we offer. Let me give you a number here. When we started in 2006, we started with 3 services. Today, what we have around more than 200 services. Can you imagine the amount of services that we have, right? So we're going to see in this training here, we're going to see something like databases, like what kind of database we have. We're going to see storage. We're going to see compute, for example. We're going to see networking and content delivery. We're going to see some of these services and what do we offer in these services. What about the global presence, right? Again, we are discussing here the benefits of the AWS. What about the global presence? When I will have this section of explaining what we call the AWS infrastructure, you're going to see the concept of what we call regions and AWS and how we are structuring this kind of infrastructure and the big difference between what we have versus our competition. And the options of hybrid cloud. If we found out that some customers, they still require to have hybrid cloud. Do we have some offerings about hybrid cloud? Definitely yes. And the most famous of these offerings is what we call VMC, VMware Cloud on AWS. You tell me, what does it mean? Does it mean that I can have VMware virtual machines running on AWS? Yes. And this can be, I can tell you, the easiest way of migration to the cloud. Because very simply, at least this is from my experience, more than 90% of the data centers that I visited in the region, they were based on VMware. If you have a different experience, please put it on the chat from a virtualization perspective. Like how many or the percentage of data centers that you have came into and you have found them other than VMware. I can say 90% it was VMware, and maybe for some telco providers it was something like KVM or OpenStack. Very little customers of Nutanix, for example, Acropolis. But the other ones, most of them, they run based on VMware. Just give me 1 second, please. Sorry. But I think now AWS using containerization, right? So containers can be an option, Hamza. So we're going to see this when we explain the compute. So from the compute options, you can have virtual machines, you can have containers, and you can have even what we call serverless. We're going to explain this when we reach the compute part. So it depends really on how the application, the customer application is working. Is it based on virtual machines, containers, or even serverless? So with VMware, as I was explaining, the easiest way to do migration is to have VMware or VMC, VMware Cloud on AWS, where simply customers can do what we call vMotion of their virtual machines from the on-premises into the cloud. And they can still manage this using vCenter. If you are familiar with VMware, vCenter is the management software to manage all of your virtual machines and your infrastructure. It's called vCenter. So you can still have your vCenter to manage your infrastructure as well. So that's usually the easiest way if I want to do migration, keeping everything I have today and just doing vMotion to some of my virtual machines on the cloud. This is again for what? This is for the hybrid cloud. If I have customers who will run their own on-premise versus they need to have some of their workloads on the cloud. Now, something else, we're going to see it again in details, but just for now, what we call the security and compliance. And this is something very important for you to explain it to your customers here. Some customers, they have a concern about security in the cloud, right? How can you respond back to their concern here? You need to explain for them what we call the shared responsibility model. And from the name, shared responsibility model, it means that some responsibilities, they are AWS responsibilities, and some other responsibilities are the cloud, are the customer responsibility. So what is the difference between these two? AWS is responsible for the security of the cloud. Of the cloud means responsible for securing the physical proximity. As you can see here, to secure the physical proximity. My physical data center, my physical server inside this data center, physical storage, databases definitely, and physical switches that we have, or my networking. But then it's the customer responsibility now to secure his data. What do you mean by this? Let me tell you a simple example. You have your data center, even today, and you have something called your firewall, right? The firewall is the first line of defense on how you are securing your data center, right? Who configures the firewall? It's yourself. You are the one configuring the policies, what to allow and what to deny. Now imagine if I configured my firewall to allow any. What happens here? It's like I opened my cloud to everyone on the internet, right? Whose responsibility is this? This is the responsibility of the customer. It's not AWS responsibility. AWS can provide for you the service like the firewall, but you know better your application, right? So you need to specify to me, what are my firewall policies? Something else. What about my encryption? If I have my data and then I chose not to encrypt my data, this means that your data is going to be readable on the complete internet. Did you get this? So we have this shared responsibility model, which means that I have, as AWS, the responsibility of the cloud, but then the customer is responsible for security in the cloud. Is this concept clear? That's a very important term you need to mention to your customers. So security is not only AWS responsibility, and it's not only the customer responsibility. We have this shared responsibility model. Is this model clear with everyone? The shared responsibility model? Because you might get a question. Thank you, Angelique, because you might get the question. Thank you, Rado, about a customer asking you about this shared responsibility model. So let me ask you this question, because definitely this is a question that you will get in your exam. So let's see this question here. In the AWS shared responsibility model, and please read the question very carefully. Which of the following options are managed by AWS customer? Which of the following options are managed by the AWS customer? What do you think? The customer will manage what? Very good. The customer will manage the network and the firewall. All right. Anything else? OS, security groups, and firewalls. Exactly. Exactly. Thanks a lot, Radu, for this. So, as a customer, I will get my server. My server has an operating system, right? It's the customer responsibility to manage this operating system, to make sure that this operating system is patched to the latest security updates, for example, right? Security groups here, this means your authorization, who is allowed to do what. It's completely up to you, Mr. Customer, if you're configuring the firewall to specify who is allowed to do what. It's your environment, so you know your environment better. We cannot decide this on your behalf as AWS, right? So in the exam, you're going to get this question, but vice versa. In the exam, you're going to get what is the responsibility of AWS. All right, so I hope this clear. So what we explained so far, that cloud computing, and that's the definition, provides the on-demand delivery of IT resources. We have explained this. It's on demand whenever you have a demand of IT resources like servers, like storage, like networking, like security. And we spoke about 3 models of deployment. We spoke about private, completely on-premise. We spoke about cloud or public, completely in the cloud. And we spoke about the mix, which is the hybrid. AWS is managing and maintaining the infrastructure, so it's the responsibility of AWS, and customers can simply focus on the innovations. They don't need to worry about the physical proximity. They don't need to worry about securing this kind of physical proximity. They need simply to think on their business and how they can innovate their applications. Fine. Is this concept clear? Is the concept clear with everyone? Any question? All right, so 10 more minutes, we finish this one, and then we go into our first break. What is the AWS global infrastructure? What is AWS global infrastructure? And here we're going to explain 3 important terms. Please pay attention. This is a very foundational knowledge about AWS. What we call a region, what we call an availability zone, and what we call edge location. What is the difference in between the 3? So let me start by the availability zone. If I want to define what is an availability zone, so this is an availability zone. The definition is the availability zone is one or more discrete data centers. So this is a complete data center. So it can be even more than one data center. So the availability zone is one or more data center, and every data center has redundant power, redundant networking, redundant connectivity to the regions, which I'm going to explain. Availability zones, they give customers the availability to operate production applications, maybe database, in a very highly available and fault-tolerant environment. So here in this case, what do I have? I have availability zone, which has like maybe 2 data centers. And then I can have the second availability zone like this, having data centers as well. And then maybe a third availability zone. So this is 1, this is 2, this is number 3. And these availability zones, they are connected with a very high speed fiber, up to 100 gig of connections here in between these. And this is what I call a region. So whenever you see on the internet something called AWS region, what do I have inside the region? If I want to define this word here, region. So AWS has a concept of the region. which is a physical location around the world where we cluster data centers. So this is a data center cluster. This is a second data center cluster. This is the third data center cluster. And as you can see here, the minimum of availability zones inside the region is at least 2. But right now, and I will show you this, right now we have 3 at least. So I'm going to show you the regions that we have and the kind of availability zones inside them. And every data center has in the range from 50 to 80,000 servers. So imagine I have in every DC around 80 servers. So in every availability zone, something in the range of 100 or 150,000 of servers. So in the region, you have something in the range of from 400 to 500,000 of servers. Can you imagine? This is just in one region. And let me tell you this, whenever I say a region is always in one country. And I have these availability zones inside the country, but they are distant from each other. So maybe like 100 kilometers away from each other. Why? So if something happened to one availability zone and one AZ, for example, failed, I can have the other availability zones up and running, right? So that's the region and that is the availability zone. So question, Hamza, it's basically doing a mirroring as a backup plan. So this depends on your configuration, definitely. And if you are doing your design, Hamza, you need to design your applications so that, for example, you have some instances running here and some instances running here. This is something that you need to design. Because if you designed your application in one availability zone and this availability zone failed, very simply, all your application is down. And that's why following something called the well-architected framework, which is how we can design a best practice cloud design here, we follow what we call reliability pillar, which means I have my applications in minimum of 2 availability zones. This is something that you need to design it. Is it clear, Hamza? All right. So, is this concept clear? The regions and the availability zones? Is this clear with everyone? Let me show you this on AWS itself. Let me show you this on AWS itself. Maybe you want to see it later on, how you can do it. Let me just share my browser here, 1 second. Here you go. So you can simply put AWS infrastructure, right? So that's our infrastructure here. That's the global infrastructure. So you can see what do we have currently? What is the latest number that we have currently? So right now we have 26 regions. That's the latest update. And we have 84 availability zones. So based on what I explained, if I have like 3 availability zones and 26 regions, if you did the math, 3 multiplied by 26, what do you get? I get 78. So how come we have 84 availability zones? Because very simply, if you went down like this, you will find some regions that they have more than 3 availability zones, like this one, for example, here, which is the North Virginia, which was our first zone. And as you can see, it was launched in 2006. Can you see the number here? Up to 6 availability zones. In general, the average is 3. So this other one as well for the Gov Cloud in the US. Another example here of North Carolina having 3 availability zones. Another example of Oregon. For example, Oregon has even 4 availability zones. You can check something here, maybe like Jakarta has 3, Singapore has 3, I guess Seoul, this one, where is Seoul? Yeah, it has like 4 availability zones here. So as you can see, the ones in blue are the regions which are already there today. Customers can use them today. And the ones in orange are the regions to come. And as you can see here, UAE region is coming very soon. We're very excited about it because I am based in UAE in Dubai, and we have a region that will come in the next 2 or 3 months that will be up and running in UAE. So we'll have another region very near here. So in order for you to be getting the latest updates, you can just go to this website, aws.infrastructure, right? And you will get all the updates about the regions and availability zones that we currently have. All right, so back to the slides. So we mentioned the concept of the regions, right? We mentioned the concept of availability zones, and we explained that this is an example of an availability zone. Inside this availability zone, I may have multiple data centers, like huge amount of infrastructure here, right? And what is a region? It's a combination of clusters of data centers. Every cluster is called an availability zone. And when you are deploying your application, you have the complete control of where do you want your data to reside. It's completely up to you. And these availability zones are constructing what we call the region, right? And you have seen examples about this one here. And again, a region is inside one country. So whenever we say UAE region, Bahrain region, or something like London region, right? So I can have the region is always in one country because of the compliance and regulations. But can I have in one country more than one region? Yes, here you go. This is the US, for example. Inside one country, I have multiple regions. So here it depends. In order for me, if I have like lots of demand inside this country, maybe we can go and get another region to serve all of this demand. Is this concept clear? Regions, availability zones? Is this concept clear? Because definitely a question or 2 questions about this one in your assessment following the training today. Any question? Okay, the last one, and then we go for the break, is what we call the edge location. And in order for me to explain it, have you ever heard about something called CDN network? Content Delivery Network. Anyone heard about this term before? Or can anyone tell us in the chat, what do I do with the CDN? What do I do with content delivery? There is a very simple term here. What do I do with the CDN network? Any idea? CDN is doing something very important to push content closer, yes, but how do we do this, Radu? We do this with something called caching. So CDN, very simply, exactly, thank you, Angelique. This CDN is doing caching, right? So let me explain this. What is caching? And let me give you the real life example. We all know about Netflix, right? And we all know that Netflix has customers all across the globe, right? Everyone has his application and he's watching movies, for example. Fine. What's the architecture? I'll give you the architecture from a very, very high level of Netflix. What do we have? We have a bucket here or a folder in the US, and this folder has all the movies of Netflix. Right? A very, very huge folder has all the movies of Netflix. And then I might have customers of Netflix maybe in Europe like this. So what will happen if this customer wants to watch a certain movie or a certain series? So the traffic, here I have my CDN. So I'm going to ask my cache. This is for the first user. Do you have this movie? So the first user, definitely, I don't have the movie. So I go all over the US, get the movie, and then I will cache this movie here and serve the movie to the customer. And then for the second customer now, who wants to get the same movie, he will go and ask the cache, do you have this movie locally? And then I will reply, yes, I have the movie locally here. So I don't need for the second customer to go all over the US and come again and face all of these delays. Did you get this? So this is the concept in general of doing caching, right? How do I do caching? This is through something called CDN, or Content Delivery Network. And where do I do it on AWS? You do it through something called edge locations. So what's the edge location? It's a smaller data center than the availability zone. If you remember, we explained availability zones, which is like a big cluster of data centers, right? The edge is now even a smaller data center, where inside the edge, we have this service that can do for me the CDN, and this service is called what? It's called CloudFront. So that is a question, again, in your exam, if you are just writing with me. Then what is the name of the service that is doing CDN? The name of the service is called CloudFront. Where can I find this CloudFront? You can find the CloudFront into what we call the edge location, which is the smaller data center that I have. Is this clear with everyone? Is this clear with everyone? Any question about this? Sure? No questions? All right. I hope that you're not asking questions because the concept is clear. Please, again, if you have any question, either to put it on the chat or unmute yourself and ask the question, or even if you want to share at any point of time your experience with this, please feel free to share your experience as well, or your opinion about this. All right, so I guess it's time for a break. We can take a break right now. So let me put for you the timer for the break. Just 1 second. All right, so let's go maybe for like a 15 minutes break. And then we come to continue. Maybe you need to stretch a bit, stand from the chair, do for you some more coffee, for example, and then we come to continue. Before we go into the break, any question? Is it clear with everyone? Are we going well with the speed? So we're not going fast or we're not going slow? What level of access does AWS have on the customer data? That's a very important question. And in general, we don't have any kind of access on the customer data, which means that there are no like situations where AWS will access the customer data unless there is something coming from a court or something coming from the law, that there is something that is really threatening in this data. Otherwise, we don't definitely touch any of the customer's data, for sure. All right, so let's go into the break. If you have any question, please, time to ask questions. If you don't have questions, then you can enjoy 15 minutes and then we come to continue.
I have a question, Rafiq. You can hear me?
Sure. Yes.
To answer you, I heard you said edge locations are like a small data center. Do they form part of the availability zones?
No. So if you, let me put my slides back here. So as you can see, so let me erase here. So what you can see here is the global infrastructure for regions and availability zones, right? So these are regions. But if you saw the next slide, for the edge locations, can you see? We have 300 edge locations. So in some cases, I can have the edge location inside my availability zone or I can have like smaller data centers like this. Here you go, which is completely outside of my availability zone.
Okay.
And that's why, if I went back here, we have 26 regions, 84 availability zones, and 310 edge locations. Did you get this?
Makes sense. Yeah.
Yeah. So as you can see, this is for, in order to have more CDNs. For the CDNs, I don't need to build the complete data center. I just want a smaller version so I can just do caching, local caching for what the users are accessing.
Okay. Thank you. That clarifies it.
Clear, Tabatsu? Clear?
Yes. Thank you.
All right. Very good. All right. Quick break and we come to continue.